Let's take a look at question 9 and 10 from the surface area exploration. Number 9, when finding the surface area of a cone or a pyramid, you are occasionally given the height rather than the slant height L. Write an equation that relates these two lengths. Well, we've said probably 1,000 times that the height and the slant height together, especially if we connect the bottom of those segments there, is going to make a right triangle. Any right triangle is going to be related, the side length is going to be related in the Pythagorean theorem. All right, here's our L, here's our R, and this one would be our height there, of course. And then which one is our hypotenuse? That's our L, it's across on the right angle. So I'm going to square my R plus square my H, and that should be equal to L squared. So when I'm solving for, let's say I'm solving this thing for my slant height, and I knew what the radius length was, and I knew what the height was, I would take the square root of both sides of this thing, and I would get that the L is equal to the square root of R squared plus H squared. Or if I was given the slant height and I needed to find the height, and that will come up in, let's say, the volume kind of questions there, I would do the opposite. I'd have to subtract over the R squared and then take the square root. So that one would be H is equal to the square root of L squared minus R squared. So I might see it in either of those two forms. Let's take a look at number 10. Notice that the lateral surface of a cone is a sector of a circle with radius L, the slant height of the cone. Therefore, the circumference of the base of the cone is equal to, the arc length of this sector. Write an equation that relates the L to the R, the radius of the base of the cone. To do that, we're going to use this little hint right here. It's equal to the arc length of this sector. Arc length formula. How do you get it? Remember, it is some fraction of the circumference of the whole entire circle. So that fraction is our angle measurement, which in this case is this Greek letter theta right here, out of 360 degrees, and then it's going to be multiplied times the circumference of the circle. And the circle this time, it would be this circle, the blue one, not the orange one. So this blue one has a radius of L, which is 2 pi times L. That needs to be equal to the circumference of the base. I'm going to take this, and I'm going to set that equal to the circumference of the base, which is already written out for me, right? That's the base circumference. So 2 pi r should be equal to theta over 360 times 2 pi times L. And I could leave it like this until I notice the fact that both sides have 2 pi, so I could divide it out. Divide 2 pi on both sides. And now I have a more compact and handy formula that relates r to L. R is equal to theta over 360 times L. That's it. It's done.